continuity checklist to determine if the function is continuous at x equals 1. So using the continuity checklist, we have to, 1, find f of c, or x, which is 1, so f of 1. 2, we have to find the limit as x approaches 1. And 3, we have to find out if f of 1 is equal or not equal to the limit as x approaches 1. So, looking at the graph, f of 1 is 2 because of the closed circle. And looking at the graph, as x approaches 1, is nothing. So, it does not exist. Therefore, this function is not continuous. So here we have to also find if the function is continuous at -2 using the continuity checklist again. So once again, we have to find out if f of -2 is the same as the limit approaching when x is -2. Okay. So looking at the graph, to find f of -2, you'll get 5 because it is a closed circle. And looking at the graph to find x as it approaches -2, you'll get 3. And they're not equal because they do not have the same value. Therefore, this function is not continuous on this graph. Here, we're supposed to find if f of -1 does exist. F of -1 does exist because as the line is passing through -1, it approaches +1. Therefore, f of -1 is equal to +1. Here, we're supposed to find if the function is defined when x is -2. If you look at the graph, the function is defined once x is -2 because of the closed circle. Therefore, the function is defined when x is -2. Number 5 is to explain how continuity and domain are related. Continuity and domain are related because if you are not given an interval or boundary points, your domain will show you where your function is continuous. Okay, so here, number 6, we have to determine where the function is continuous. So, the function will more than likely be continuous when it's positive, not when it's negative because of the radical. You cannot have a negative number in the radical. And not when it's 0 because you cannot have a 0 denominator. So we're going to cross out negative and 0. So now we'll equal the denominator to 0. Well, put greater than 0 since the denominator has to be greater than 0. Add 2 to both sides. Bring down 7x, which is greater than 2. Divide out 7. And now your answer would be x is greater than 2 over 7. So the function is continuous when x is greater than 2 over 7. So here we have to determine where the function is continuous. To find where the function is continuous, we have to set the denominator equal to 0 using greater than, less than, or equal to signs. So we're going to factor out the denominator and we'll get x plus 7 and x minus 6 and equal them to 0. So now we'll have x plus 7 equals 0 and x minus 6 equals 0. Subtract 7, then you have x equals -7. And add 6, and then we'll have x equals +6. So the function is continuous